We are familiar with the fact that pulleys are simple machines which makes our work easier to do. Now, depending upon the assembly of the pulley, it can either help us apply the effort in downward direction, or it can help us lift up heavier loads by applying a smaller effort. See, in this type of pulley system, there are two pulleys which are attached with one axle upwards, this one, and there are two more pulleys which are attached to another axle in a downward position. And all these pulleys are attached with a single rope. This type of pulley arrangement is known as a block and tackle system. So let's see how a block and tackle system moves. Here you see two pulleys are fixed at a point, that is, they are not moving, while two other pulleys are moving along with the load. That is, the load is acting in upward direction. That is, the load is moving upwards along with these two pulleys, whereas the effort is coming down when we apply the effort on the free end of the rope. Now at equilibrium position, there must be some force which is acting on these strings so that the load does not fall. Therefore, this force which acts on the strings of the pulley is known as tension. So let us try to find out that where does the tension acts here. So the tension will act on the string which is connecting the lower block of the pulley so that the load does not fall off. So the tension would be acting on the point where the string is connecting the upper blocks along with the lower blocks. So one tension acts on this string, another tension would be on this string, one more here and another here. So we have four strings which are connecting the four pulleys, and we have four tension which are acting on four of the strings. Now since this is a string which is wound together in the pulleys, so the tension T is equal in all the string segments. Now in this last string, this tension T is balancing also the effort. So this tension is being transferred on this string as well. And all the tension would be acting in upward direction. So from this, you can see so many tensions are acting on this block and tackle system, and this is supporting the load as well as the effort at equilibrium position. Now in this arrangement, you saw 4 tension is supporting the load. So load can be written as T plus T plus T plus T, which is equal to 4T. So load can be written as 4T, or the 4 tension which is acting on the 4 segments of the string, whereas the effort is being only balanced by this particular tension on one segment of the string. So effort can be written as equal to only. Now we need to calculate that how much magnification of effort we can obtain by using a block and tackle system. So for that, we need to calculate the mechanical advantage. And you know, mechanical advantage is the ratio of the load by effort. So the load here is equal to 4T, or 4 times the tension which are acting on each string, and E is equal to T, that is the tension which is acting on only one string. So the mechanical advantage would be 4T divided by T, which is equal to 4 because the tension gets cancelled out. So mechanical advantage for this type of block and tackle system would be equal to 4. Now notice one very important thing, that the mechanical advantage is actually equal to the total number of pulleys which are used in this combination. That is 2 pulleys in the upward block and 2 pulleys in the lower block. So the mechanical advantage is equal to the total number of pulleys which are used in this system. In this case, we had used 4 pulleys. It was an even number of pulleys in the block and tackle. So is this fact true also for odd number of pulley system? Let us try to find. So here you see we are using 5 pulleys in this block and tackle system. 3 pulleys are fixed together, whereas 2 pulleys are moving along with the load. So here we have a total of 5 pulleys. So similarly, let's find out where the tension acts on the strings which are attached to the pulleys. So the tension can be denoted by T, which will act on each of the string which is supporting the lower block. So tension would be here on the second string, third string, fourth and fifth. So 5 tension on each string segment is supporting the load, so that in equilibrium the load does not fall off, and this last string will transfer the tension on this string which is balancing the effort. So the load is being supported by 5 strings, and 5 of the tension on these strings can be written as equal to the load. So load is equal to 5T, whereas the effort is being balanced by only one tension on one particular string. So effort is equal to T. So to find out the mechanical advantage, we'll again follow the same step and divide load by effort. Here load is equal to 5T and effort is equal to T. Therefore, mechanical advantage is equal to 5T by T. The T factor gets cancelled out and you get mechanical advantage is equal to 5. So again notice that we had 5 pulleys in this system and the mechanical advantage has also come out to be 5. So the mechanical advantage is equal to the total number of pulleys which are used in this system. So suppose we use n number of pulleys in this block and tackle system. So what would be the mechanical advantage? Well, if we use n number of pulleys in a block and tackle system, the mechanical advantage will also be equal to n or the total number of pulleys which are being used. Now mechanical advantage is equal to load by effort. So if mechanical advantage is equal to n, load by effort will also be equal to n. Or you can write effort is equal to load by n. So see, in a block and tackle system, the effort is being multiplied n times in lifting a much heavier load. Therefore, the load which is being lifted up or the resistive force is much greater than the effort or the applied force. Therefore, by using a block and tackle system, we are obtaining a multiplication of force. So, a block and tackle system is also known as a force multiplier. And similarly, for every machine, we need to find out the efficiency. Efficiency, you know, is the ratio of the mechanical advantage divided by the velocity ratio. Mechanical advantage we have found out to be n when n number of pulleys are used in a block and tackle system. So what about the velocity ratio? Well, velocity ratio is the displacement of effort divided by the displacement of load. That is how much distance the effort is moving in order to move the load. So see here in this animation, when you apply an effort in the downward direction in a block and tackle system where there are 4 pulleys, the effort is moving a total distance which is being moved by all the strings. So suppose each string is moving a distance of d, then the effort would move a total distance which is moved by all the strings. So how many strings do we have here? We have 1, 2, 3 and 4. 4 strings are supporting all the pulleys together. So the distance which is travelled by the effort is equal to 4 times the d or 4d. Whereas in comparison, the load only moves a distance of d, that is a distance moved by a single string segment. Now suppose we had n number of pulleys in a block and tackle system. So here the effort would move the total distance which is moved by n number of pulleys. So if each pulley moves a distance of d, then n number of pulleys would move a distance of n into d. So when you have n number of pulleys in a block and tackle system, the effort would move a distance of n into d. But the displacement of load would be same, that is only d. So to calculate the velocity ratio, we need to calculate the displacement of effort divided by the displacement of load. So just now we calculated the displacement of effort to be n into d, and the displacement of load is d. So the velocity ratio can be calculated to be n. That is equal to the number of total pulleys which are used in a block and tackle system. Now coming back to the efficiency is equal to mechanical advantage divided by the velocity ratio. And for a block and tackle system having n number of pulleys, the mechanical advantage and the velocity ratio both are equal to n. So efficiency would be n by n, that is equal to 1. But this is only true in case of ideal situation where the friction, the mass of the pulley and the mass of the string is not considered or considered to be negligible. But this is not true in every situation, because the lower block of the block and tackle system also adds up to the entire load. So if we consider the weight of the load to be L and the weight of the lower block along with the pulleys to be W, then L plus W is the total load which the effort needs to lift up. Now consider we have n number of pulleys in a block and tackle system. So there would be n number of string in that system. So the total tension of that block and tackle system would be n into T. That is tension in each string multiplied to the total number of string segments. So these total number of string segments will balance the total load, that is the weight of the load plus the weight of the lower block of the pulleys. So L plus W will be equal to the tension in all the strings, that is n into T. So the load plus the lower block of the block and tackle system is being supported by n into T. And effort in this case would be equal to T, because only one string is supporting the effort, that is the free end of the string. Now if we consider two equations as L plus W is equal to n into T, that is load by the total weight of the lower blocks is equal to n into T. This can be considered to be equation 1. And the effort is equal to 1 tension, that is effort is equal to T. And this can be considered as equation number 2. So suppose we divide equation 1 by equation 2, what we get is L plus W divided by E is equal to nt divided by T. So this can be written as equal to n, or we can write this as L by E plus W by E is equal to n. Right? L by E, that is load by effort, is equal to n minus W by E. Now is this term familiar to you, load by effort? Yes, load by effort is actually the mechanical advantage of this block and tackle system, which in this case is equal to n minus W by E. So the efficiency expression would change in this case because the velocity ratio is remaining the same, but the mechanical advantage is changing. The new mechanical advantage that we found out was n minus W by E, but the velocity ratio remains as n. Therefore, the efficiency or eta changes to be n minus W by E divided by n, which is equal to 1 minus W by n into E. So, the lower block so the weight of the lower block is reducing the efficiency eta from 1 to less than 1. So efficiency in this case, when the lower block is adding up to the weight of the load, would be less than 1. Therefore, to obtain a block and tackle system which has a higher efficiency, what we need to do, we need to reduce the weight of the lower block and make it as light as possible. And also, we need to reduce the friction which is present in the pulley bearings and in the strings.